Okay, we jump all the way from chapter 6 to chapter 12. You got a few problems that deal with systems. Keep in mind, the first thing is trying to let you look to see where two graphs cross. So if I got the straight line x plus y is equal to 6, and I plot my 0, 6, and my 6, 0, that is the definite line this way. If I take my straight line x minus y is equal to 4, when x is 0, y is minus 4, and when x is 4, y is 0. So these two lines cross at the point 5, 1. You got a few definitions you need to keep in mind. Inconsistent will mean that they don't intersect. Perfect example of inconsistent. If I gave you x plus y is 6 and x plus y is 4, those two lines are parallel. They're not going to intersect. Also, dependent. Really, dependent simply means that they're the same line. If x plus y is equal to 6 and 2x plus 2y is equal to 12, if you plotted these things, it would be one line on top of the other. So this really doesn't make sense. You don't deal with that too often. Most of our problems are going to come from the inconsistent, from the consistent type. Okay, we got two methods. The first method is what we call the addition method. And it's very, very simple. You add them together, you get rid of a variable. In this case, the plus y minus y goes away. X plus x is 2x, 6 plus 4 is 10. 2x is 10, so x is 5. But you're not through. You got to find the y. So you plug the 5 back into here, and you get 5 plus y is equal to 6, so y is 1. So that means that we have the point on our graph is the point x is 5 and y is 1. And that's what we got on that last page when we showed the graph. Okay, they don't stay that simple. I got 3x plus 2y is 8 and 4x minus y is 7. Well, I got to get rid of one of these letters, so I'm going to get rid of the y by multiplying the bottom equation by 2. So that's going to give me then 3x plus 2y is 8. The bottom is going to give me 8x minus 2y is 14. I add them and the y's go away. 11x is 22. So that says then that my x is going to be 2. So if x is 2, you plug it in. 3 times 2 plus 2 times y is 8. And y comes out to be 1. So the point that we've got for this one is the point 2, 1. All right. We got one here where I've got to multiply both equations by something, and I've got to change the sign also so that we can get rid of one of the letters. Now you decide which variable you want to do. Here I'm going to go ahead and get rid of the x. So I multiply the top by 3, and that's going to give me 12x plus 9y is 21. And I multiply the bottom by minus 4 because, as I said, we got to have an opposite sign. So that gives me minus 12x minus 20y minus 32. So I get minus 11y is minus 11, so y is 1. Now you can plug that 1 back into either one of those original equations. I plugged into the top one. I get 4x plus 3 times 1 is equal to 7. 4x is 4, so x is 1. So our point is the point 1, 1. Okay, that is another method. Many people don't like the substitution method because it's got steps that you have to go through. But this is a very important procedure of knowing how to use the substitution method. And my next problem will make you see that. Okay, this is our problem here. 5x plus 4y is 9, and x plus y is 2. Your first step in the substitution method is to get one of the variables by itself. I chose this equation to get the y by itself, so y is 2 minus x. Now, what you just got, you plug into the other equation. So in place of that y up here, I put a 2 minus x. And then you do what we did the first day of class. This is a linear equation. So you solve. drop your parentheses, 5x plus 8 minus 4x is equal to 9. And 5 minus 4 is 1. And you subtract the 9 and you get 1. And then you always go back to step 1. We just got the fact that x is 1. So if I plug that back into my step 1, I get 2 minus 1 is 1. So my point again is 1, 1. Forgive me for all those. I'm making the problem different from my end. I like it to come out nice and easy. That's a substitution method. Even though it's harder, it's important that you know how to use it. And this next type problem is going to certainly show you that you have to do that. In the old days, when I gave the handwritten test or typed out test, I always put this problem on there because it reviews so much of what we've done. X squared plus y squared is 25. That's from way back there in another chapter, and that gives me a circle with a radius of 5. X plus y is equal to 7. It's a straight line. So let's plot those two things. I plot my circle with my radius of 5. I plot my straight line, y-intercept is 7, x-intercept is 7, and I draw that straight line. And notice that that line is going to cross that circle twice. Well, I've already shown you where it crossed because I worked the problem out. But watch the substitution method. You're going to take and get the y by itself, and that's 7 minus x. You plug it in. Now, you got to be real careful with this. When you square this binomial, the easiest way to do it is to put it down and multiply it by itself. Otherwise, you're probably going to miss this 14x. But it comes out to be 49 minus 14x plus x squared. Now, I got x squared plus x squared is 2x squared minus 14x. Subtract the 25 and I get the 24 here. I divide everything by 2 and just makes it come out nice and convenient. I got x squared minus 7x plus 12. Factors of 12 are 12 and 1, 6 and 2, and 4 and 3. We're going to use 4 and 3 because that's going to give us this 7 right here. So x minus 4 times x minus 3 says that x is 4 and x is 3. Now, as I said a while ago, always go back to step 1 where you saw. So you let x be 4 here, and 7 minus 4 is going to give me a y value of 3. You let x be 3 there, and 7 minus 3 is going to give me a y value of 4. Now go back to our graph. 4, 3 is this point, and 3, 4 is this point. Okay, so I hope you can get this section 12 with a few problems worked in it. Be ready to take that test Thursday of this week. Good luck.